Good afternoon, class.
Good afternoon, Mrs. Bowie.
Sit down. Thank you. All right, then. We've completed the topic on basic numeracy. We will now look at the new topic which I love teaching, and it is algebra. Okay. Because I'm so interested in it, like you should be, I decided to go and do a bit of reading. And when I did, I actually found out some information I probably didn't really know. Okay, so I've just got it here for your information so you know where algebra comes from. Okay, it says the history of algebra goes back thousands of years. The ancient Egyptians and Babylonians, you know, if you've read your Bible, you will know what I'm talking about. They used algebraic symbols in the 17th century BC. Remember Pythagoras? He also founded the Pythagoras theorem. Okay, and he lived between 585 and 500 BC. To me, it looks like he was 85 years old. And he was a Greek mathematician who developed many algebraic techniques through his study of numbers. Okay, then I went on to read. I thought, now, where does algebra really comes from? And then I found out that the algebra owes its name to the title of a book. However you want to pronounce it, I tried my very best. It's probably Hisbal, Jabra, Wal, Mukabala. It sounds like Muslim to me. But this book was written by an Arab mathematician. I actually thought that algebra was founded by some other mathematicians, but not an Arab mathematician. Okay, in 825 AD. Okay, so if you see this, it sounds like algebra, but it comes from the book that this particular person wrote. If you are interested, you can go back and read the encyclopedias about the different mathematicians, and you can read a little bit more. And make it a bit interesting for yourself, instead of listening to us all the time and finding out from us all the time, try and find out some information, because that's what I did. Okay, we are not going to talk about history, but that's just a little bit of background on algebra. Okay, in algebra, an expression is made up of, we use algebraic expressions, it's made up of constants and variables. Variables are also called pronumerals, and they are letters of the alphabet that is used. So it's made up of constants and variables, which are also called pronumerals. And all of these are called terms. In grade 12, we also use the word term again, but we use it in looking at number patterns. Okay, in the expression, I've just written an expression here, 4xy plus 3x minus 4. X and y are variables, or they are also pronumerals. And again, they are actually letters that are used to represent numbers, or sometimes they can represent quantities as well. Okay, x and y are variables, or they are pronumerals. We'll talk more about variables later on. Not this year, maybe in grade 12. And they are also pronumerals. And minus 4, because it's not attached to any letter, it is called a constant. That means it doesn't change. It remains the same whatever the value for x and y are. Okay, 4x, y, 3x, and minus 4 are called terms. They are terms in the algebraic expression, 4xy plus 3x minus 4. Okay, the number before the pronumeral is called the coefficient. So in this case, looking at 3x, 3 is the coefficient of x here. So the number before x, or even here, 4 is the coefficient of x, y. So in algebra, letters are used, they're actually used to represent quantities, or they are used to represent numbers. When we say 4xy, it means 4 is multiplied by x, which is multiplied by y. Okay. Now we go on to adding and subtracting of algebraic terms. The rule for adding and subtracting says that you can add and subtract only those terms that are alike. You can add and subtract only like terms. For instance, 4x plus 9x, they are like terms. So you can add 4x and 9x, and you get 13x. I usually say that if you add 2 pigs and 3 dogs, you can come up with maybe 5 animals, but really you cannot add because pigs are different from dogs. My daughter in grade 8 came home one time and says, Mom, I don't understand this X and Y business that we are doing. And I said, what's hard? And she goes, I cannot add X and Y. And I said, yeah, you cannot add X and Y because they're different. It's like you're trying to add 1 pig to 1 dog. And she goes, oh, I still don't understand. So you can only add dogs and pigs and pigs. You cannot add dogs and pigs. It's the same. So 4x plus 9x is 13x. Okay, I've got 4x and 5y. They are unlike terms, so you cannot add. 4x plus 5y remains as 4x plus 5y. Here, 14x squared plus 3y minus 4xy plus 5x squared minus 2y. The like terms are x squared and x squared. In other words, those are the ones that will have the same pronumeral or the same variable. So 14x squared plus 5x squared will give us 19x squared. 3y minus 2y will give 1y. And because there is no other xy, minus 4xy remains the same. Okay, 3ab minus 2a squared b plus 3ba minus 9ba squared. Kila, tell us which are like terms.
Minus 2a squared. Sorry, no, what? Like terms.
No like terms?
No.
Okay. Siegfried, let's see what you say. Which of these are like terms? Kila says there are no like terms.
3ab and 3ba are like terms, and 2a squared b and 9ba squared are like terms.
Okay. Don't forget, when you multiply, for instance, like I said here, this sentence here, in algebra, letters are used to represent quantities or numbers, which means this A and B represent the same number as B and A. Okay, except that you're not, for these two, they'll represent the same numbers, but the thing is you're squaring one, so that makes it different. You're squaring this A and this A. And remember, if you're multiplying 3 times, let's say A represents 2 and B represents 4. 3 times 2 times 4, which is 24, is exactly the same as if you multiplied 3 times 4 times 2. So 3AB is the same as 3 multiplied by this. That's the same answer we will get is 24. Okay, and similarly for A squared, B is the same as BA squared. So 3AB minus 2A squared B plus 3BA minus 9BA squared. Margaret, what is the answer for this?
6AB
Okay, 3AB plus 3BA is 6AB.
minus 11A squared B.
Okay, minus 11A squared
squared.
B. You can even write it the other way around. You can say 3AB plus 3BA is 6BA minus 11BA squared. But usually the letter that comes first in the alphabet is the one you also put first. Okay. Before we go on to the exercise, I think there was a mistake yesterday. Tamaku was plotting the points invisibly on the number line. And I think letter F, where R is equal to minus 2 on 3, he pointed here. Do you remember? Yes. Yeah, he should have pointed between 0 and negative 1, which is negative 2 thirds, which is negative 0.6, around negative 0.6. Okay, that was just a correction from yesterday. All right, the exercise you have to do is on the screen. There. It should take you 2 minutes to do A, B, C, D, and E.
Later on, like this, as you converse to algebra and you go to test, if you don't put it correctly in alphabetical order, we get it wrong, right? It doesn't.
No. Okay, first answer should be 34x. George, your answer for B, please.
Any 7A plus 7B.
7A plus 7B is correct. C, Andrew?
13A squared plus 14A.
Good. Jake?
6x.
6x is correct. E, don't forget you have to stand.
11A squared plus 2A.
11A squared plus 2A. Okay. Continue. it? Minus. Minus or plus? Okay, you should have completed the next 5. Pon relay, your answer for letter F.
21m squared n plus 7mn.
Good. Agnes,
3 plus 8a minus 6a squared.
okay. Raylene,
2n.
2n. Yes. Garanamo,
3ab squared.
3ab squared or 3b squared a, yes. Miriam,
38c.
38c is correct. It's not finished yet. Next 5. All right, I see that many of you have finished. Letter K, then
Plus 11D.
good. Chutaili.
9mn plus 4m plus 3n.
Okay, 9mn plus 4m plus 3n. M Hekoi,
Negative 3x.
negative 3x is correct. Velma, N.
7m minus 7n.
7m minus 7n is correct. O, Vui,
4a plus b squared minus 6ab minus 3 squared
4a plus
plus b squared
b squared
minus 6ab
minus 6ab
minus 3 squared.
minus 3 squared, which is 9.
9.
Okay, that's correct. The last three. It's a good exercise for speed and accuracy. Finished? I'll give you 2 more minutes. Okay. Solomon, you turn the answer to letter P.
5x minus 12 minus 6x squared.
5x minus 12 minus 6x squared is correct. Tamaku, letter Q.
8mn plus m squared n minus 5m n squared.
8mn plus
M squared
m squared n.
minus 5m n squared.
Okay, minus 5mn squared. Kyle, Letter R.
Negative 6x squared y cubed minus 3x y squared.
Okay. Negative 6 x squared y cubed minus 3x y squared. Am I correct? Yes. Okay. Note for adding and subtracting, you only add and subtract those terms that are alike. Otherwise, you don't add and you don't subtract. Right. In the next lesson, we are going to continue with algebra and with simplifying, but where we have brackets. And then later on, we'll be looking at indices in algebra as well, which is a little bit more difficult than in numbers. All right, for next lesson, this is what you are going to do. There is an exercise based on the previous topic, which I would like you to do as a revision exercise. You are going to do it for homework, and we are going to correct it in class. And if you volunteer, or if I call your name to come and to answer the questions, you're going to come to the board and explain your answer. Okay, there are, I think, 9 questions. And then later on, we'll continue with algebra. All right, the keyword for the pilot teacher is algebra. All right, I have to let you go for your next lesson. Good afternoon, class.